Hey guys, and welcome to this video on the Python programming language and the machine learning algorithm called a decision tree classifier. So in this video, we're going to classify a car to see if it's accepted, good, or very good based off of its features. So what I did was download a data set called car.data, and I'm just going to open it here. And I got car.data from a website called archive.ics.uci.edu, and we can see the data here. So what I did was I transformed it to car.csv. So I transformed it to a CSV file so we could see the columns of the CSV file. And the first column is called buying, and buying stands for the buying price of the car. And the possible values within this column are V high, which stands for very high, it's high, med for medium, and low. And then next we see a column called maint, which stands for the maintenance price. And the values here, of course, are V high and high, med for medium again, and low. Next, we have something called doors, and doors is the number of doors that the car has, and the possible values here are 2, 3, 4, and 5 more. Next, we have a column called persons, and persons is the number of passengers that can fit in a car. So the possible values for this column are 2, 4, and more. And then next we have a column called lug boot, and lug boot is the size of the luggage capacity, and the possible values for this are small, med for medium, and big. And then we have a column called safety, and of course, safety tells us how safe the car is, and it can either be low, med for medium, or high. And then finally, we get to our target variable called, oops, let me just put that back. So our target variable called values here, and this tells us if the car is unacceptable, accepted, good, or very good. So the possible values are unac, which stands for unaccepted, and then ac or ACC, which stands for accepted, and then of course good and vgood, which stands for very good. Okay, so I took this CSV file and I transformed the data. I transformed it from this categorical data, at least the independent variables. So these are the features that we want to train our data set on. And I kept the target variable or the dependent variable as it is. I kept it categorical, but I transformed again these features into integer values. So once I did that, I got this car integer accept y.csv file. And so now the numbers basically correspond with the category. And I have a video on how I did this, at least for one column. So you guys can see that video. I'll be sure to put a link to that video below as well, so you guys can see how I did that. And like I said, the numbers now correspond to the different possible categories for each column. So for example, 4 under buying is now equal to V high. So wherever we have 4, that's where we had V high in car.csv, at least for the buying column here. And for the maintenance column, it actually happens to be the same. 4 stands for V high, so we see 4 here, and we go back to car.csv, we can see V high. The doors, you can see that we still have 2 for doors, and we basically changed for doors. There was a value called 5 more, and we just changed that to equal 5. So this is pretty much what I did, and then of course I kept the target variable the same. So we're going to work with this car underscore integer underscore accept y.csv file. So I just want to make it really easy for you guys to go ahead and get started, and I'll put a link to the CSV files, to the original data, all on my GitHub as well, so you guys can check that out. So finally, let's go ahead and get started with this program now that you kind of understand the data and what I've done with the data, how I've already manipulated the data. Again, I just want to make this really simple for you guys to get started with a decision tree classifier program. Okay, so first thing I'm going to do is I'm going to put a comment in the code and just tell what this program does. So this program uses a machine learning algorithm called a decision tree classifier to classify a car as unacceptable, acceptable, or accepted, good, or very good. Okay, so that's how we're going to do it. And so the first thing that we should do is import our dependencies or libraries. So I'm going to put in comments here what we're going to be doing. We're going to import the dependencies / libraries. Okay, so I'm going to import numpy as np, and then I'm going to import pandas. I said no, not np. There we go. I'm going to import pandas as pd, and then I'm going to use our machine learning library called sklearn.tree to get our or import our decision tree classifier. Okay, now let's create a data frame from our data set. So we're going to create a data frame from the data set. And to do that, I'm going to create a variable called df for a data frame. And we're going to use pandas for this data frame to read our CSV file. So pd.read underscore CSV. And we need to input the location of the CSV file. So we put it in these quotes here. And it's located under datasets, cars. So datasets, look like my computer's loading a little bit. Give it some time here. So once it's done, what we're going to do, we're going to load it under datasets here to my left, then cars, and then car.data. And then we have to give it, of course, the name. So it will be car underscore integer underscore accept y with a capital .csv. Okay, so it look like my computer's done trying to load or done freezing. So again, we have to say data sets / cars with a capital C / car underscore integer underscore accept capital Y .csv. So that's this data set here. And I'm actually going to make it a little bit bigger for you guys. Okay, so that right there gives us our data frame. And let's take a look at it. Maybe we'll just print the first five rows of the data. So print the first 5 rows of the data set. And to do that, we can just say print, and then we do df.head method. And so that's going to give us the first 5 rows of our data frame. So if I run this, I click run up here and run decision tree. Let me make sure that it's the right one. So I have another file called decision underscore tree. This one here is going to be called decision capital tree, capital T tree. So run, not that one. So I need to I'm going to click here actually, and I'm going to run. Oh, it's not there. Okay, so let's not run that then. We're going to run this here. So I'm just going to click run. And now we have the option to run our decision tree Python program here. Okay, and so we can see that it's running down here, down below. And we're going to give it some time. All it's going to do is print out the first 5 rows of our car integer except y.csv data set. Okay, and so next what we're going to do is split our data into independent variables and the dependent variable. And I'm going to show you guys how to do that using the data frame. We're going to give it some name. So let's see. I'm sorry I don't have a faster computer, but while it's trying to print out the first 5 rows, we can continue on. And it looks like it's actually done now. So if I just kind of scroll this up. All right, what we can see is the first 5 rows again. So starting from 0 all the way up to 4, we can see the values here. So they should match the values in the data set as well. And it looks like they do. So perfect. All right, let's go ahead and go back to our program. And like I said, let's continue on. So we're going to split the data into the independent variables and the dependent variable. Okay. So all we have to do is say x, well, we're just going to create a variable called x underscore train because it's going to be our training data of our independent variables. So that's the x's. And we're going to set it equal to our data frame df dot loc. And what we're going to do is we're going to get all of the rows and we're going to get all of the columns from buying to safety. Okay. And I'll probably put here in comments what it's doing. So it gets all the rows in the data set from column buying to column safety. All right. Next, we want to get our target variable. So I'm just going to say y underscore train. I'm going to create that variable. And I said y because y is the dependent variable. That's our target that we want. And we're going to say df.loc, and we're going to get all of the rows from the values column. Okay, oops. And then I'm going to put in comments here what it's doing. So get all of the rows in the data set from column values. All right. So now we've split the data. Let's create the decision tree. So I'm going to create a variable. Well, first let me put in comments here. I'm going to put create the decision tree classifier. So I'm going to create a variable. I'm going to call it tree and set it equal to decision tree classifier. And we're going to put in some parameters. So we're going to give it a maximum of 3 leaf nodes. So we say max leaf nodes equals 3. And what you probably want to do is play around with the max leaf nodes to make your model more accurate. But for now, I'm just arbitrarily choosing 3. And let's see, random state is going to equal, it really doesn't matter the number here, but I'm just going to put 0 for now. You could put any number there for random state. And there's actually some documentation on the sklearn website, and it explains a little bit more about what random state is. but basically, if you're training with the same data and things like that, you want to keep that number the same. The number itself doesn't really matter, but keeping the number the same will matter, or could matter. All right. So anyways, we're going to move on for now. Like I said, it's just supposed to be a simple program to create a decision tree classifier. So next thing we're going to do is train the model. And to do that, we're going to use a method called fit. So we just say tree.fit. And fit's just another way of saying train. And we'll put in our training data. So x train and y train. All right. Okay, and now what we can do is we can make our prediction. So let's see here, make our prediction. So I'm going to create a variable called prediction. And I'm going to set it equal to tree.predict. And within here, we're going to put in a list of lists, and then we're going to make our prediction. So what type of input do we want to put in here? Let's see, input, we're going to put in, we want the buying to equal very high. We want the maintenance to equal high. We want the number of doors to equal 2, and we want the number of people that the car can hold to equal 6. So that's really good. And then we want our lug boot, lug underscore boot, to equal medium. So the size of the luggage capacity is medium. And then the safety of the car will be 3. So 3 is high, right? So it will be high. So let's go ahead and put that in here. But we can't use those actual categorical variables such as high, v high, anything like that. So we have to put in the integer values associated with them. So high is v high is the first one, right? So v high is associated with the number 4, and then I have high here for maintenance. So I'll put a comment here, and for maintenance we're going to put 3 because high is associated with 3. And doors, of course, the number of doors stays the same, so we just put 2 here, except for when it comes to the categorical variable 5 more. Persons equals 6, so still 6 here. Well, persons equals 6. So you know what? Let's change persons to, no, we'll keep it at, no, let's change it persons to 2. They can only hold 2 people, so we'll put 2 here. Okay. And lug boot is medium, so we're going to put 2 for medium under lug boot, and then safety was high, and so that will be 3. All right. And so what we can do now, we can print our prediction. So here we will print the prediction, and I'm just going to say print prediction, and let's run this. So I'm going to go up to run here, and now you can see that we have the option to simply run decision tree here. So I'm running it, and let's give it some time. And of course, it's going to come back with either as unacceptable, good, very good, or acceptable. And this is unacceptable. So at least that's what our decision tree thinks it is. But we haven't checked really how accurate our decision tree is. We haven't played with these hyperparameters, and there's all sorts of things that we can do to check how accurate our model is and to improve upon it. But like I said, for this video, it was just going to be short and simple to get you guys started. So thank you guys. Be sure to leave any questions you have in the comment section, likes. Don't forget to hit that subscribe button and that like button. And if you found this video helpful, please share it. And as always, guys, thank you for watching, and I'll see you all in the next video.